Hello, AP Stat students. This is Mr. Hazelhorse coming to you live from room A08. I want to take a few moments here today and share with you some information about some methods that we can use to analyze categorical data. We're going to talk about both marginal and conditional distributions and how they fit within a two-way table. So let's get a rolling here. So let's start out with a two-way table. In your textbook, on page 12, there's an example problem called I'm going to be rich. And this is a great example of a two-way table. A two-way table is just simply a way that we can organize data within two categorical variables. Now, the key being here as we work with a two-way table is that we want to use this to analyze categorical data. So while there are numbers involved within the data collection, the key here is the two categorical variables that are really making up this problem. And our two categorical variables can be broken down to their position within the table. We have ourselves both a row variable and a column variable. The row variable in this problem is their opinion that one day they are actually going to strike it rich. And you can see we've taken their opinion and broken it down into 5 different categories. Almost no chance, some chance, but probably not, a 50-50 chance, a good chance, and almost certain. Those are the categories. Within those categories, we have collected data, but the variable themselves are those subgroups of opinion. Our column variable is being represented by gender. So not only have we collected just the opinion of these young adults, but we've also broken it down within their gender. And that's going to allow us to do some comparison here before we get to the end of this video. All right, so as you can see, a two-way table is pretty simple. The key here to recognize is that the data that matters to us is just within the row and column variable. The total row and column would not actually be data. That's just numbers that we use to actually help us do some calculation. So the only data that really matters to us in this problem would be our data contained within this area. Again, anything outside of that is just total data. All right. So let's break this down a little bit further. So we can take a two-way table and we can break it down to what's known as a marginal distribution. And a marginal distribution is just simply looking at the distribution of values within one of the categorical variables. All right, so in any two-way table, we can make two different marginal distributions. In this problem, we could make a marginal distribution based on opinion, or we could make a marginal distribution based on gender. Those are our two categorical variables. So for my example, we're going to break down a marginal distribution based on opinion. And so here would be an example of that, all right? Basically what we're doing is we're eliminating one of the categorical variables, all right? So in this case, we've eliminated gender, okay? And so oftentimes a marginal distribution can be represented as either the percent of data within each of those categories or the count. A majority of the time we're going to deal with percents because counts in and of themselves really don't necessarily mean a whole lot to us, right? If I tell you there's 194 people in the almost no chance category, that doesn't make much sense to us, all right? But if I tell you that 4% of the data is in the almost no chance category, well, that gives you a much better picture. We have a stronger understanding of percents than we do just counts, okay? And so you can see here we've broken that down, and as we take a look, teenagers appear to, or young adults we should say, appear to feel very confident in at least having a 50-50 chance of striking it rich someday. We look at well over 80% of our data falls within those lower three categories, a 50-50 chance, a good chance, and almost certain. So definitely youthful optimism being represented within our marginal distribution. All right. So as you can see, a marginal distribution, very simple for us to create. Oftentimes, we're going to take a marginal distribution and represent it within a pie graph. All right. So let's talk a little bit about conditional distributions. All right, a conditional distribution is we are going to take the distribution of data within one specific category of one of the categorical variables. So we're actually going to break the data down further So we'll be comparing two variables, but looking at a breakdown of just one specific category. And each category in a conditional or in a two-way table would have its own separate conditional distribution. All right, so in this example, we could have 5 different conditional distributions based on opinion, because we had 5 different categories for that variable. And we could also have 2 different conditional distributions based on gender. So for our example here, we're going to break down our conditional distribution based on gender. And I've actually created 2 different conditional distributions. All right, so I have a marginal distribution, a conditional distribution based on gender. And so you can see here we've taken that female data and we have broken it down. What do females feel their opinion of striking it rich is? And then we've done the same thing on the male side, all right? And so the conditional distribution just allows us to break that two-way table down into a smaller part, all right? We can kind of zoom in and look at one specific piece of the two-way table. In this case, we can look at females, and then we can also look at males, all right? So if you take a look at that table, what do you notice here is the difference between males and females when it comes to that opinion that someday they might strike it rich. And if we take a look, most of our categories are actually pretty well balanced, all right? We see the very first category, almost no chance, males and females are essentially equal in terms of percentage. And then in the some chance, that's where our distributions start to differ. All right, we can see a large difference. 7% is pretty significant in terms of the difference between how females feel compared to males and vice versa. And then we also see another big gap down in the almost certain category. We can see males are almost 4% more likely to feel that they are almost certain they are going to be rich. That could just be the overconfidence of most young males. But as we compare those two distributions, ultimately what we want to be looking for is what we refer to as an association. All right? We can say that there is an association if we can use one variable to help predict the other. All right? So as we take a look in this problem, based on our two-way table, we would say that males are more likely to be almost certain that they are going to strike it rich. Okay? Again, we had a somewhat significant difference, a 4% difference between males and females in that category. Now, if our two distributions were essentially equal, I don't mean exactly equal, but they were relatively close throughout, then in that case we would say there's no association. We would say that gender does not appear to impact or have any association on the opinion of whether or not students are going to strike it rich. All right? Now, oftentimes, as we talk about association, we might take the information in a two-way table and look at it graphically. All right? Again, graphs are going to be a very important concept within this course. Most people are visual learners, and so they like to have a breakdown of data graphically. And so a common type of graph that is used with conditional distributions would be what we refer to as a segmented bar graph. Basically, what we have here is the love child of a pie graph and a bar graph combined into one. And if we take a look at those two different breakdowns, the graph that we have on the left here, that would be the conditional distribution based on gender that shows an association. Again, if we compare the parts of those graphs, you can see that there's a big difference between the purple segments between males and females, and again, we also see a large difference between the green segments. Now, the red, yellow, and blue segments are essentially the same. All right, if we compare the graph on the right, that would be an example where we'd say there's no association between the variables. If that would have been the segmented bar graph of our conditional distribution, if we look at those two segmented bar graphs, they essentially look the same, okay? And so that's just a way, again, that we can represent data graphically, and as we analyze categorical data, that's really what we want to be looking for. We don't create conditional distributions just for the sake of creating a conditional distribution. We create one to see if we can find an association between two categorical variables. And so this is an important concept that we want to begin to understand and begin to look at as we work here through AP Stats. Well, that brings us to the end of your first flipped classroom video. I want to remind you here, my expectation of you after you've completed this video is to complete the form below. And so please take a few moments to do that. Again, I'm going to ask you to rank your level of understanding somewhere between 1 to 5. And again, if you rank yourself 3 or below, I just ask that you leave me some comments. Make note of what concepts within this video may have been a little confusing to you. And I can use that information to guide the work that we're going to do in class. So hope you guys are having a great day, and we'll see you soon.